Hi class, welcome to How Does That Work with Mrs. Jackson. Have you ever wondered how the lighting on the control panel in your car works? Well, today I'm going to show you. We're going to look at each component in this circuit and simulate it using Multisim. And after watching this video, you will know how the lighting works in the control panel of your car.
Those bright lights on the control panel at night. Let's locate the parts of the car that make up this electrical circuit for those bright lights. The power supply, or battery as it is commonly called, is located under hoods in most cars, but also located in trunks in some cars. The fuse is located in a panel on the driver's side of the vehicle below the steering wheel. The switch and rheostat are located to the left of the steering wheel. At night, with the lighting on the control panel and the dashboard of a car, we check how much gas we have in the car, the engine's temperature, and how fast we're driving when the patrol pulls us over. Now, let's locate these components in Multisim and simulate the circuit. First, we're going to locate the power supply, select the ground symbol for the power menu, and a dialog box appears. Select DC power and OK. With the same ground symbol, select the desired fuse size. The switch is under the basic menu, and I will select the single pole, single throw switch. Next, use the basic menu again to select the rheostat or the adjustable resistance. Then, I will select a voltmeter from the indicator menu and an ammeter from the same indicator menu. With all the components placed in the circuit, I will connect them in series. To connect them in series, I left-click on the positive end of the power supply and connect it to the positive end of the ammeter. Next, I will select the negative end of the ammeter and connect it to the switch. The negative end of the switch is then connected to the fuse. The end of the fuse is connected to the rheostat. Next, I will connect the rheostat to the negative of the power supply. I will also ground this circuit as a reference for the power supply. Lastly, I will connect the voltmeter. Now, I will press the play button to simulate or run the circuit. Next, I will turn the switch on. Notice the voltage across the rheostat is equal to the voltage value of the battery. The values of the current and the voltage across the rheostat shows the circuit is operating correctly and following Ohm's law and Kirchhoff's voltage law. Let's talk about how this circuit works. A DC voltage is applied to a circuit to produce current through a lamp to provide light. The circuit has a fuse which protects the circuit from a short circuit. The control panel light operates from a 12-volt battery that is activated when I insert my key into the ignition and I press the start button. The switch is the same switch used to turn the headlights on. The rheostat sets the amount of current through the lights to light the control panel. The higher the current is, the brighter the light, which also means the smaller resistance values produce more lighting. This illustrates Ohm's law, which states current and resistance are inversely proportional. When current goes up, the resistance goes down. Circuits will overheat if the resistance is too small to handle the current or the fuse in the circuit is not sized according to Ohm's law. And the fire department will be called.
Now I've shown you how the lighting works in the control panel in your car, and you have learned as the current increases, the lighting increases. which is Ohm's law at work. Now I want you to go out, grab those keys, turn on those headlights, and watch what you've learned in action. This is Mrs. Jackson signing off. Thanks for watching.